Okay, so what we're going to go over today is basically the fire hose appliances and nozzles, that is in the way that they associate to the basic pump class. So why we're here? One of the reasons that we're going to hit this is that as a pump operator and as a firefighter, you need to know the tools that you're using. The tool that we use to deliver water is nozzles. And the way we get water to the nozzle is through the hose. So you need to have a solid understanding of what you're using to be able to correctly and efficiently apply water to a fire. So fire hose construction could be single jacket. That's your forestry hose. It's basically made out of one layer of material. The older stuff was cotton. New stuff is polyester. This is called the weeping hose. It's actually made, you'll actually get some water seepage through this. All the rest of the fire hose is double jacketed. You've got an outer protector, and then you've got the inner liner that carries the water. And it has the older the hose, the greater the friction loss. The newer the hose, the less the friction loss, just by the way they change the materials and whatnot as construction, as technology has improved. Hose lengths are in 50 to 100 feet. All your LDH, anything up for your LDH is all in hundreds. Any of your attack lines are down into your 50 foots. So your attack hoses are 1 inch, 1.5 inches, 1.75 inches, 2 inch. 2.5 is can be used for attack or supply, and your LDH supply line is 4 or 5. Suction hose is that's your hard suction off the side of the truck. When it comes to hose sizes, especially for pump operations, you need to know what size you're using for to be able to correctly figure friction loss. If you're to know the gallonage that you want to flow out of the nozzle, if you know the gallonage that the nozzle will deliver, the gallonage that the hose will carry, and what you want to deliver, those are what you need to be able to accomplish to be able to set your pumps correctly and to overcome friction loss and be able to develop the correct pump pressure. After the next class that we're going on, this is actually, these two are actually in one course. As far as one section is the hose and nozzles, and also the math that goes along with it. Just for sake of ease, we're just going to go over the nozzles and the hose today, and the next one we do is actually going to be just dedicated to the correctly figuring friction loss. Your 2.5, that can be used for an attack line, big water, big fire, big water. So you can use it as an attack line. You can use it it can be used interior, can be used exterior. It can be used exterior. It can also be used to supply the blitz fires and whatnot. What Scarborough also has as an intermediate line in between the 2.5 and the 5 inch is we do have 3 inch on each truck, and that's meant to go with the. You can use that for numerous things. It's meant to go with the blitz fires, but you can also use it for a short length if you just need to hook 2 trucks together to double your water supply from 1,000 gallons to 2,000 gallons. You can use the 3 inch just to be able to do that for an earth tanker operation. It's lightweight, it gives you some flexibility, and gives you some options. Couplings, the older hose is made out of brass, newer hose is made out of composites. You have a male end with the threads, you have a female end with the internal threads. This is all on your smaller hose. Anything up to 2.5, 3 inch, this is all going to be, this will be the standard, the male female type connections. When you get to the large diameter hose, obviously they have the Storts, quarter turns, whatnot like that. One of the things that, just as a point of reference, is that when people sometimes have trouble threading the hoses together. Reach back to basic fire school and remember the Higby notches on each coupling. On there are notches on the lugs that where you put together. They are lined up so that no matter that those notches, when you line them up, they will always start when they line up the threads so that they start each time. When you're coupling these together, make sure that you don't get them cross-threaded. Okay, it makes it very easy for them to blow apart. The other thing is make sure that you're using the right style thread. Most of the hose that we have is all IP, iron pipe. Occasionally, some departments do have, they do order the smaller hose, 1.5 inch, 1.75 in national standard, just like 2.5 and 3 inch. When you get to those smaller, when you get to those smaller ones, if you don't, especially if you don't get the threads matched correctly, they will not either go together at all, or they will go together, seem like they tighten, but they will come apart. So, and again, anything up LDH is all dealing with storts and quarter turn. All right, nozzles. You got smooth bore. Smooth bore nozzles have been around forever. They were the original nozzles. They went from this to a fog nozzle. Now we've gone back to using solid bores because they do have a lot of good applications with them. They're simple to operate. They don't get clogged as easily. You can move a lot of water and you don't have to pump them at such a higher pressure. One of the things with a solid bore that does help is that if you have what's called a stream straightener, where it goes onto the body of the nozzle itself, it adds a little bit length, and it also gives the water a chance to start into a spin to be able to go out the nozzle and give you a good penetrating nozzle. When you're using these, you're going to get these, you're going to use it for deep penetration. You're going to use it for getting into the seat of the fire. If you need to use if you want the stream to break it up, you have to bounce it off the ceiling, give it a broken stream effect so that you can make smaller droplets. That all goes into hose handling and all that sort of stuff. The flow of a solid bore nozzle is determined by the tip size. Okay, the tip size should be stamped on it. The more modern ones are. A lot of the older ones aren't. But the tip size determines the orifice at the end determines how it's a given gallonage per minute of how much it flows. Fog nozzles, again, they're just making a broken stream. They can variable width. You can have a wide pattern. You can have a narrow pattern. It is not a solid stream. It's still a broken stream. It flows smaller droplets. One of these, you take a little bit more maintenance. You do have to make sure that you don't get them all clogged up with rust and dirt and stuff like that. And you have to operate these at a higher pressure. Each fog nozzle it's a given that you're going to be pumping it at 100 PSI to make it operate correctly and to get the correct flow that you're supposed to out of it. Well, I got some people wanting to get in, so hang on just a minute. There. All right. So fog nozzles can come in a few different models. One is the automatic adjusting nozzle. Talked with Lieutenant Bennett this morning, one of them, and how he would describe it. They're called basically, old Chief Carson used to call these crowd pleasers. No matter what flow you put through these, whether it could be the 150 gallons a minute, or it could be 30 gallons a minute. No matter what you put in for gallonage, the stream is going to look good. It's going to give you a workable stream. That was the idea of it, that no matter what flow you had in it, is that you'll have a working stream. The problem is that as a firefighter and as the person on the nozzle and as the pump operator, if you haven't done your math correctly, or or something's wrong, it'll look like that stream is doing great. But the fire's not going out. The reason is because you're not putting enough gallonage on the fire. It's a false sense of security. You can't tell whether you've got a good flow or not. So we don't have many of these. Fixed gallonages, obviously, they're either open or closed. These will actually, you've got to pump these at, the nozzle pressure has to be 100 PSI. And you have to have the correct friction loss figured out for the hose line to get your correct gallonage. If this is a 150 gallon minute nozzle, you have to figure out the math and pump, give yourself an engine pressure that'll give you 150 gallons at the nozzle. You will be able to tell, because if you will not get a working stream out of this, it'll be a very broken stream. You won't get very much distance. It won't come out with a lot of velocity. Adjustable gallonage. This is a little bit better. Back in the day, you were able to select the gallonage that you wanted, so that if you wanted a fire, if you only needed a fire that needed 30 gallons a minute, you could select it back. The pump operator would only have to be able to pump the pressure to give you 30 gallons a minute. If you needed a full flow or up to 150, you'd have to do the math to get it up to that. One thing that you could do is with these that was a little bit handy is that if you weren't getting the correct flow and you still needed to be able to have a workable stream, you could click it back one notch and you would get a working stream. But you're still going to run into the problem, you're not putting enough water on the fire. So the whole secret of these is that the pump operator needs to know what the gallonage is set at on the nozzle so that you can pump these nozzles at the correct pressure. They need to be a standard, and if there's going to be a change, the pump operator needs to know that. So nozzles are given, the pressures are given. A smooth bore, whether it's a master stream or whether it's a smooth bore, whether it's for a hand line, is pumped at 50. If you're pumping a smooth bore and it's a fixed set, say like on a deck gun or one of the blitz fires, you pump that at 80. The fog nozzles, whether it's a master stream or a hand line, are always pumped at 100. Just as you look below, fog nozzle is 100, smooth bore is at 80. So that's kind of an important thing to remember. You want to know as a pump operator what your nozzles are doing so that you're able to pump those correctly and you're not throwing somebody around at the end. If you have somebody out on the end of a hose line and with a solid bore and you crank that at 100 because you think it's a fog nozzle, someone at the end of that hose line is going to go for a ride. So you need to be able to know what you're using and what's on the end of the hose line to be able to pump these correctly. Okay. Apparently we had a technical difficulty that someone just told me about. So there. All right. So the volume of a hand line is again dictated by the nozzle size. So if you've got a 1/4 inch nozzle, you're only going to flow 13 gallons a minute. If you've got an inch, if you've got an inch and a quarter, you're going to do 328. So it varies through. Our hand lines in Scarborough have the 15/16 tip. They're 185 gallons per minute. Those are on the cross lays. Solid bores also work well with the foam system. They also work well with the calves. So that's why we have that set up the way it is. If you go down to a fog nozzle, they can be from 45 to 250 gallons a minute. That's the gallonage or the volume that you can actually put through them. Master streams, you have a smooth bores, 1 3/8 is 500, up to 2 inches, 1,000. Your fog nozzles are built to, some of them are variable, some of them are fixed gallonage. The ones are like on the end of ladder 1, that's a fixed gallonage at 1,000 gallons a minute. But they are variable. You can change them from a wide pattern down to a solid, down to a narrow stream, okay, or a straight stream. So you have other types of nozzles. You have Pearson nozzles. They're made to drive through walls, sheet metal and stuff like that. They have a hardened tip that you can punch through. You can actually hit on the end of them with a flat-headed axe or a Halligan, beat them through, and then when you hook a line to it, it sprays water out the tip. These are the old Breslin nozzles. They were basically portable fire extinguisher, portable fire sprinklers. You'll be able to punch a hole in the floor, fight a fire from above for a basement fire or whatnot. They rotate and spray water around under the floor. Nozzles should be inspected. Obviously, every time you do a truck check, you want to make sure you check and make sure your nozzles are on, make sure that they're workable, make sure you can operate the bale, make sure they're clean. You don't want to drag them through the mud and the dirt and stuff like that. If they are dirty, you want to rinse them out. Take care of the threads and make sure when you do clean the threads, look inside, see what the ball valve looks like. Fog nozzles, on the end of the fog nozzle tip, there's a little rotator on there, a little spin that has teeth on it that's supposed to help break up the water droplets into finer mist. Make sure that those are there. Any problems, you want to let the lieutenant know. So we're going to go back. That was the end of the slides. We're going to go back and go through just some of the slides that we did miss, because there's some things I want to go over. With the hose sizes, you need to know when you're pumping a truck what you're pumping. To be able to generate enough water, the correct flow that you're trying. If you're trying to flow 250 gallons a minute, you need to know, are you trying to pump through 250 gallons a minute through a 2.5? Are you trying to do it through 5-inch? Are you trying to do it through 3-inch? All of that comes into play to be able to develop the correct friction loss, be able to correct engine pressure to overcome friction loss. It used to be that you would just, if you can just set, there's schools of thought that you can just set, okay, we know that this is what we have for nozzle, this is what we have for hose, this is what you set for engine pressure. That's good to start with. That's good to be able to get you a tank water, get you a starting place. The problem when it comes, when you start pumping trucks, when you start adding hose lines, whether it's another cross lay, they taking a line off the back, you're pumping to a different truck, you're pumping to a sprinkler system. Now you have to start using your engine operator and pump operator skills. You need to know what the hose will carry for water, and you need to know what the water is coming out of. If you have a solid bore nozzle, one of the things that you are going to deal with this is that depending on the nozzle, one of the things that you should talk about is reaction force. You have to know what the nozzles are doing for you for that. Reaction force is how much back pressure you put onto it. That means if you put the wrong pressure on there, how much is it going to take to push the guy or the person holding that nozzle down? You can actually hurt someone very, very easily if you overpump these. So that's why you need to know what you have for nozzles. You need to know what tip sizes are on there. like I said, if you know at the beginning of your shift that you have a 15/16 tip on there, and that's going to flow 185 gallons a minute at 150 because you have 200 feet of hose line, now you have a place to start. But say they add another 100 feet of hose because you're further away from 200 feet. So now you need to be able to overcome that. That's why you can't just go by the givens. You have to know what the friction loss is, what the gallonage is for the nozzle. You need to know it to make yourself a proper operator. The same thing is for when you get into master streams. You need to be able, because typically in master streams, you're going to have a good water supply set up, and you're going to be pumping to a different truck, or you're going to be pumping relay operations. You build it from the nozzle back. How much water do you want to flow? If the fire takes 1,000 gallons a minute, okay, you need to know, first off, can I pump that? Do I have the water supply for that? Am I able to work it? And then you need to be able to work the math so that you're able to pump that master stream at what incident command wants you to pump it at. So that's why you need to know all these parts and all these tools that's part of your pump system. So, okay, so that's the end of the slides there. And we're going to go back to, get rid of this. We're going to go back to us. Okay. We got any questions this morning? Go ahead and unmute if you got a question. No questions this morning? Okay. So that's it for today then. So that didn't take very long. So thanks for joining in, and we'll catch you guys the next time.